Building cloud-native applications from scratch. Building cloud-native applications from scratch. Cloud-native applications are becoming more and more popular as companies look to gain the advantages of the cloud, including scalability, agility, and cost efficiency. But what exactly does it mean? To build a cloud-native application from scratch? In this article, we'll explore the key concepts of cloud-native development and provide a step-by-step guide to building your own cloud-native application. What is a cloud-native application? Let's start with a definition of cloud-native. The Cloud-Native Computing Foundation, CNCF, defines cloud-native as an approach to building and running applications that exploits the advantages of the cloud computing delivery model. This means that cloud-native applications are designed to take full advantage of the cloud scalability, agility, and cost efficiency. At the heart of cloud-native development is the belief in the power of small, independent services that work together to form a complete application. These services are typically designed to be stateless, meaning they do not rely on any shared state or information. Instead, they communicate with each other using APIs and other interfaces. Another characteristic of cloud-native applications is their use of containers and container orchestration systems like Kubernetes. Containers provide a consistent runtime environment for services, while orchestration systems manage the deployment and scaling of those services. Step 1. Choose your development framework. The first step in building a cloud-native application is to choose your development framework. There are several popular options available, including Spring Boot, Node.js, and Ruby on Rails. These frameworks provide a solid foundation for building cloud-native applications, with features like dependency injection, web server integration, and database management. When choosing a framework, it's important to consider your team's skill set. If they have experience with a particular framework, it may be the best choice for your project. Additionally, you should look for frameworks that are actively maintained and have a community of developers supporting them. Step 2. Design your services. The next step is to design your services. As we mentioned earlier, cloud-native applications are composed of small, independent services that work together to provide a complete application. Begin by identifying the individual services your application will require. Once you have identified your services, it's important to design them in a way that maximizes their independence and scalability. Each service should have a well-defined API and should not rely on any shared state or information. This makes it possible to scale individual services up or down as needed without affecting other parts of the application. Step 3. Containerize your services. Now it's time to containerize your services. Containers provide a consistent runtime environment for your services, making it easier to manage and deploy them. Docker is the most popular containerizer tie-in platform, offering a simple way to package services into containers. When containerizing your services, it's important to ensure that each container is self-contained and has a clear definition of its dependencies. This makes it easier to manage and deploy your service in a consistent manner. Step 4. Deploy to Kubernetes. With your services containerized, it's time to deploy them to your chosen container orchestration system. Kubernetes is the most popular choice for cloud-native applications, providing powerful tools for managing and scaling services. When deploying to Kubernetes, you'll need to create a deployment file that specifies the desired state of your application. This file should include definitions for each service, along with any requis. Red configuration and resources. Once your deployment file is ready, you can use the Kubernetes command line tool, kubectl, to deploy your application. Step 5. Monitor and scale your services.